smart systems for applications in electrical sciences for the past 2 years, with this being the third edition. Also, Technician, a technical symposium, has been held for over 2 decades. It gives me immense pleasure to extend to you all a very warm welcome to the inauguration of ICSSES-2025 and Technetium 25. Now, may I call upon Honorable Chief Guests and dignitaries onto the dais. May I now request Dr. O.D. Naidu sir, Senior Principal Scientist, Hitachi Energy Research, Hitachi Energy, Bengaluru, to come onto the dais. I kindly request the volunteers to escort the dignitaries. It is my honor to call upon Dr. Madhusudan C.S. Sir, Group Director, System Engineering, ISRO, Bengaluru, to step onto the dais. I respectfully invite Sri D.K. Namzundappa Sir, Secretary, SCCS, to join with esteemed dignitaries on the stage. May I now request Dr. Shivkumar Sir, Joint Secretary, SSES, and CEO, SIT, to come on to the dignified dais. With great pleasure, I invite Dr. S.C. Dinesh Sir, Principal, SIT, to come onto the stage. I now welcome Dr. Rashmi Ma'am, Organizing Chair, ICSSES-25 and HOD of Electrical and Electronics Department, to step onto the dais. May I warmly welcome Dr. Vinayaka Kane Sir, Technical Chair, ICSSES-25, to the dais. I now request Dr. H.S. Sridhar Sir, Coordinator of Technetium 25, to please step onto the stage. I request Student Coordinator of Technetium 25, Mr. Yashas R., 8th Semester, Department of EEE, to come onto the dais. Let us begin this auspicious occasion by invoking the Almighty. Now, I request Mr. Bhaskar Kashyap from ECE for the invocation song.
Padi Gajamukha, Padi Sumukha, Padi Siddhinayaka, Padi Suradanayaka, Padi Gajamukha, Padi Sumukha, Padi Siddhinayaka, Padi Suradanayaka.
for the invocation. ICSSES and Technician 25 has been meticulously organized to encourage research and innovation among scholars, to initiate a thought process among research aspirants, and to showcase the technical skills and abilities of undergraduate students.
This conference is a reality due to the kind support from our sponsor, PP Passive Technologies, Bengaluru, and technical co-sponsor, IEEE Bengaluru section.
Now I request Dr. Rashmi Ma'am to deliver the welcome speech.
Good morning. At the outset, I submit my respectful pranamas to the lotus feet of His Holiness Dr. Sri Sri Shivakumara Mahaswamigaru, Founder President, SSES, and Sri Sri Siddhalinga Mahaswamigaru, President, SSES, and I seek their blessings to begin the inaugural function of the International Conference on Smart Systems for Applications in Electrical Sciences, ICSSES-2025, organized by the Association of Electrical Sciences and a national level symposium, Technician 2025. Dignitaries on the dais, invitees, session chairs, co-chairs, authors, sponsors, participants, deans, HODs, faculty and staff members, and my dear student friends. Print and electronic media, good morning to you one and all. It is both an honor and privilege to stand before you as we embark on this exciting journey of knowledge, collaboration, and innovation at International Conference ICSSES 2025 at Siddhaganga Institute of Technology, Tumkur. The Association of Electrical Sciences comprises of 4 departments, namely Electrical and Electronics Engineering, Electronics and Communication Engineering, Electronics and Telecommunication Engineering, and Electronics and Instrumentation Engineering. The conference on Smart Systems for Applications in Electrical Sciences is being organized by the Association of Electrical Sciences under the aegis of IEEE Bangalore section. This is the 3rd international conference, and the second one was organized on 3rd and 4th May 2024. This conference brings together brilliant minds from around the world to exchange ideas, explore new trends, and discuss the cutting-edge developments in the field of smart systems, power systems, power electronics, communication technologies, automation, instrumentation, and much more. It is also an opportunity to forge connections that will shape the future of our profession. We have received 1,266 research articles under 10 different streams, namely wireless communication, AI and ML applications, secure communication, signal processing, vehicles, smart sensors and automation, VLSI design and materials. Researchers from USA, Russia, China, Vietnam, Iraq and Oman have submitted their research articles. Each of these research articles are reviewed by 3 independent experts, and 175 papers are selected for presentation and publication in IEEE Explore. These papers will be presented in 6 parallel tracks in hybrid mode. All the presented papers will be published in IEEE Explore. It is our tradition to begin the International Conference and Technician 2025 with an inaugural function. We requested Dr. Ori Naidu sir, Senior Principal Scientist, Hitachi Energy Research, Hitachi Bangalore, as Chief Guest to inaugurate the International Conference and to deliver the inaugural address. Through our well-wisher, Professor Mahadev Prasanna sir, Director, IIIT Dharwad. Dr. Ori Naidu sir is kind enough to accept our invitation. I extend hearty welcome to respected Ori Naidu sir. Technicium is an annual technical symposium organized by the Association of Electrical Sciences. We invite a well-known technocrat to inaugurate the symposium and hobby project and to deliver the keynote address. We invited Dr. Madhusudan CS, Group Director, System Engineering, Professor U.R. Rao Satellite Center, ISRO, Bangalore, to inaugurate Technicium 2025 and Hobby Project Exhibition. And also he is going to deliver keynote address. I extend hearty welcome to respected Madhusudan sir. We request that our Honorable Secretary, SSES, respected Shri P.K. Nanjundappa sir, to preside over the function. He consented to our request and I extend hearty welcome to Shri P.K. Nanjundappa sir. It is my pleasure to extend hearty welcome to our respected Dr. Shivumaraya sir, CEO SIT and Joint Secretary SSES. He is always supportive and guiding force in all our activities. I extend hearty welcome to our beloved principal, Professor S.V. Dinesh sir, who motivated and encouraged us to organize this conference ICSSES-2025. I also welcome Dr. Vinayaka Kelu, coordinator of this conference ICSSES-2025. I welcome Dr. Sridhar HS, coordinator, Technicium 2025. I welcome Mr. S.S.R., 8th semester student coordinator, Technicium 2025. He received financial support from Sri Dhayanand Vyas, our alumnus 1985 batch. He is the CEO of CPPAS Chip Technologies, Bangalore. I extend hearty welcome to Sir Dhayanand. I extend hearty welcome to IEEE Bangalore section and ExCom members of IEEE. I extend hearty welcome to members of Advisory Committee, Organizing Committee, Technical Program Committee, Session Chairs, Co-Chairs and authors of the articles. I extend hearty welcome to Deans, Head of the Departments of Electrical Sciences, Head of the Departments of all the branches, faculty, staff members and my dear students. I also extend hearty welcome to friends from print and electronic media. I request you to give wide coverage in print and electronics media. Thank you. I wish you all a productive and enjoyable conference. Thank you.
I request Dr. Dayan sir, PP Passive Technologies, to please come onto the dais. Thank you, sir.
Thank you, ma'am, for welcoming all the dignitaries to the conference. I will also welcome Dr. Rashmi ma'am to the inaugural function.
To give us this year's ICSSES and Technician report, I welcome Dr. H.S. Sridhar sir.
Good morning to one and all here. Seeking the divine blessings of His Holiness, Dr. Sri Kumara Swamigalu, Founder President, Sri Siddhaganga Education Society, I offer respectful pranam to the lotus feet of of His Holiness Sri Siddhaganga Mahaswami, President in Siddhaganga Education Society. Acknowledging the presence of distinguished guests, delegates and students, I, Dr. Sridhar Richard from Department of E&E, would like to deliver a brief report regarding conference ICSSES-2025 and Technician 25. Association of Electrical Science, which comprises of Department of Electrical and Electronics Engineering, Electronics and Communication Engineering, Electronics and Instrumentation Engineering, and Electronics and Telecommunication Engineering of Siddhaganga Institute of Technology, is conducting third international conference on smart system for application in electrical science ICSSES 2025 under the IEEE Windows session. Aim of the conference is to bring together a leading researchers, academicians, and industry experts to discuss and explore advancement, challenges, and innovation in the field of smart systems applied to electrical science. Conference will serve the platform to bring to knowledge exchange, networking, collaboration among the professionals in academia and industry. Now I will give a report regarding Technician. Technician is a national level student technical symposium being organized annually under Association of Electrical Science of Siddhaganga Institute of Technology. This symposium provides perfect platform for students to exhibit their technical and managerial skills which enable them to competent in the technical world. Technician 25 includes 7 technical events, namely hobby project presentation, techno quiz, line follower, robo race, final, hardware debugging, and techno management. This year, we have 66 participants for hobby project, 78 plus participants for techno quiz, 43 for hardware debugging, and more than 48 for final, 15 for line follower, and 11 for robo race, and 12 for techno management, which shows enthusiasm of the students participating to showcase their skills and innovations. Around 700 plus students from various colleges across the states, including SST, are participating in different events. I hope all the events will be huge success with all your active participation. Thank you.
Thank you, sir. Vipat Jyoti Parabrahma, Vipat Jyoti Janardhana, Vipo Haradipa Pani, Vipat Jyotir Namostute. Light is a symbol of prosperity, auspiciousness, and abundance.
I now request the Chief Guest, Dr. O.D. Naidu sir and Dr. Madhusudan CS sir to inaugurate the event by lighting the lamp. I also invite all dignitaries on the dais to join them.
Sir, close, sir. Sir, close. Sir, close. Sir, madam, munde bani sir, munde, madam, munde, sir, smile, sir. Bitter, sir.
Thank you all. Now, I would like to call upon Ms. Varsha from EEE to introduce the Chief Guest for the event, Dr. O.D. Naidu sir.
is a part of Hitachi India. He received PhD degree in electrical engineering from Indian Institute of Technology, Kharagpur. He has been with Hitachi Energy since the year 2009 and has over 18 years of experience. He is a researcher and an expert in the field of power system protection, fault location and control monitoring, and grid management. He has developed innovative technologies for power system fault protection and monitoring. He has filed 65 patents and published 70 plus journals, international journal and conference papers. He holds 35 graded patents in the area of power system protection and fault location. His research interests include power system protection, fault location, monitoring, modeling, inverter-based resources, renewable integration, artificial intelligence applications to power system protection and monitoring. He is a senior member IEEE, is a member of CIGRE and contributed to various CIGRE working groups. Delivered multiple keynotes and tutorials in IEEE conferences. Recipient of Young Innovator on Entrepreneur 2022 Award from INB. Thank you.
Thank you, Varsha. Now, I request our beloved Chief Guest, Dr. Odi Naidu, sir, to kindly release the conference proceedings.
Madam, side. Sir, side. ಮಣಿ ಅದು ಕಾಲೇಜ್ ಇದ್ಬಿಡು ಫೋಟೋ ಚೇಂಜ್ ಮಾಡು. ಸರ್ ರೆಡಿ ಸರ್.
Thank you, sir. I consider it a great honor to welcome our chief guest, Dr. Odi Naidu, sir, to deliver the inaugural address.
seeing all this thing. So today, you see, industry required multidisciplinary business is important to really tackle today's problems, especially the energy transition side. So if you can see all the activities when the students from the various branches, I think it is very important to collaborate together and invent something which can be helpful for the energy transition. So today I would like to talk different technologies which can be useful to the very important around energy transition. So let me quickly introduce myself. It's not very done. So my name is Dr. Odi Naidu, currently working as a senior principal scientist at Hitachi Energy. So I spent a good time in various departments, including starting from the power system application development, and from the last 10 years, I am extensively doing research in power system protection and monitoring, and also the artificial intelligence applications in the power sector. So today I would like to talk about a very important aspect of technology evolution in the electrical engineering. As you can see from the slide, the most of the carbon emissions, because every country is really worried about the temperature like this and a lot of weather changes and it leads to a lot of problems. But if you can really focus into that, the most of the emissions really not mostly coming from the electrical generation. For example, you are firing so much of coal and it introduces a lot of emissions into the atmosphere, and that may lead to the event the people are afraid. There is a change of 1.5 degree temperature in coming forward. So to prevent that, a lot of changes are happening, especially in the electrical engineering, or if you can consider the whole energy landscape. As you can see, more recently, 64 countries, which are accounting almost 89% of the global emissions, are announced their net zero targets. You can see in the map, all the red ones, including India, is committed to get the achieve the net zero by certain date. Maybe in Europe, maybe 2050, 2040, but India is committed to the 2070 without hampering our development. And coming to the how we are really achieving, what is the pathway to really achieve the carbon neutral energy system. As you can see today, in 2020, we are predominantly depending on the coal-based generation, almost like 80% of energy, which is coming from the coal, and 20% is coming from the renewable energy systems. But if you can see the another scenario, 2050, it is almost, you can see 80% of this should come from the renewables like wind, solar, and then many other systems. And if you can see the electricity demand wise, enormous growth is expected in the electricity demand due to the various factors, because the industrial, they can double their energy demand, and also the buildings are growing up, and due to the urbanization, almost 50% of the energy is growing by 2050, what we have today. Especially in the transportation sector, it requires almost 30x growth, especially in the because of the electric vehicle integrations are going on. You can see that China or certain Western countries already adopting a lot of, they are moving slowly into the electrical vehicles because they have already well advanced infrastructure, especially for charging. But if you really want to achieve the carbon neutral energy system, which requires a lot example, we need to make a sustainable production solution that needs a lot of research in the material science and also the different areas. And again, a lot of importance is growing electronics, power electronics and its usage. And finally, if we really want to design, control and operate a complex system, for example, electrical systems, because of digitalization and advanced concepts. So I would like to touch upon what are the triggering factors to the renewable energy growth. So one aspect is that there is a lot of pressure on this. We have to reduce the carbon and also increase the renewable energy resource. There is a regulatory pressure, and also more importantly, the climate goal is very important to be independent. So, for example, energy security is one of the very important aspects. And more recently, you might see during the Ukraine and Russia war, even today also they are targeting the power station. Because that is a very critical role. You can imagine without the power for a day or two, especially in the urbanization time, it's very difficult. You may not get your water. Forget about the other facilities. So that is the reason we need to be independent. Today we are importing so much coal, even oil, but we should be make use our own renewable energy which is coming from that. And also the economy, but the more important is technological advancements. See, a lot of advancements are happening, especially in technology. See, floating solar panels, floating wind farms are coming up, and also wind turbine sizes are enormously increasing. For example, one wind turbine today is commercially producing 12 megawatts. So if you want to build a thermal power station, it may require almost like 8 to 10 years to really make it an operator. But now we do, just if you have a key or somewhere, you can do it in just months of time. So that's where you want to build a 500 megawatt of thermal power plant with a lot of infrastructure. So here you can see, you just put it 20 to 30 turbines to you get that. So a lot of advancements are coming up. As a whole, you can see the overall, which I would like to tell you. In India and China, both are adding the renewable as well as even the grid generation also. Like today we can see in the last budget also they are announcing they want to promote more nuclear to really balance the system. But if you can see the Western world, like US or Europe, even they are retiring their coal plants and increasing more wind and solar power. As a whole worldwide scenario, you can see the red part is going declining, which is oil and coal. Dependence they are reducing and they are increasing more and more wind and solar systems. So again, the land is very precious. Many times we may not get enough land to keep our solar panels or install our wind turbine. So we are well utilized in especially this source. For example, offshore wind is predominantly is available. In India also, almost 5 to 10 gigawatt is announced in the western in Gujarat. As you can see here, a lot of advanced technologies are really needed to even export that. For example, you can see it is like floating. That is like it's like a substation basically. The substation have all the transformers, all the transformers. This one, if you can really see inside, a lot of technology is required. See, only electrical engineer cannot design such a substation. It requires a lot of knowledge on the ocean, it requires a lot of knowledge from the mechanical engineering, instrumentation, even communication experts to really design such a substation where it should be floated and you have to balance all the dynamics, and at the same time it should be export that power to the shore. And that requires a longer distance transmission systems which should be more efficient, is important. For example, you see the HVDC systems, high voltage direct current systems. In the olden days, so the biggest challenge to go for these technologies, it has a lot of conversion losses because we are always use our loads in our home in the AC loads, but the power is also produced in AC, again you are converting DC, again DC to AC to use it. So it is a lot of conversion technology, so that what is happening, because of the conversion we are losing some energy. So that's where we need to focus a lot. As I touch energy, we really focus on the material research, especially the power electronics and even silicon, a lot of different technologies we have done. And more recently we have reduced almost 2/3. The loss conversion also reduced to 2/3. So that means that whenever we are reducing the losses, means indirectly we are generating the energy. So that is also important. And more importantly, as I told you, wind and solar, even away from the load center, we need an efficient power transmission system. That's where you can see, for example, even we are able to connect in one of the substations here, you see offshore wind, almost 3.6 gigawatt of wind is transferred to the UK grid, and another one even north of the village we are connecting. Even India is planning to connect the village through undersea cable. Now the feasibility study is going on, so that the time difference, 1.5 years, our time difference we want to utilize to really regulate the solar energy, because evening time the solar energy goes down, the loads are increasing. At that time we need more power. But if we can connect the neighboring countries to this kind of technology, we can exchange, people are working towards the one sun, one grid, one energy kind of concept. But of course, that requires a lot of communication technologies and many and so on. So these are the complex projects we already completed. Even as I told you, the equity one, we are not at completed, it's more recently we have said. So if you only want to be a kilometer, we are going to connect the Mumbai. So ideally, see what we are studying in our textbook, minimum 100 kilometers is really required to use the HVDC transmission, but no. Because of this efficiency, because of the right of way through and good control which we want it, we are connecting to this thing. So as you can see here, so many flagship projects are going utilizing this technology. Because India is announced almost 100 gigawatt of renewables they want to integrate in the grid. But unfortunately, most of the energy is at the western side, the Gujarat and the Rajasthan, those areas. Most of the load centers are the center of the country or even for the northern side. So that requires long distance HVDC, and we already announced so many good projects and good installations, and we prove that this technology will really help in transmit the huge amount of power without any minimum losses. The second aspect of that, to really see the major challenge in the EV vehicle design is that battery and its management. And the size of the battery also one of the design parameters, especially in terms of the economy point of view. If you can consider the total weight of the bus or the vehicle, the battery consumes more weight than the car. So to mitigate that, what is another comes a new technology called a fast charging technology. The fast charging technology is that how it works. I will tell you, can see this picture. the bus comes and stops in the bus stop, if passengers will board and depot, during that time the bus will start. So that, we can reduce the battery size. Instead of putting a bigger battery for a longer distances, we can keep a smaller battery design, but prefer the flat charging. You see, in the 15 seconds, it can take around 200 plus kilowatts. That means that, you see, you can imagine this much energy suddenly something is taking. It may reach, the existing protection system or control system is that the existing protection and control system thinks that it could be a disturbance or a fault. But ideally, it is not a fault. It is just one of the loads is switching on and it is taking power. So, what is important here is that we have to need to redesign entire our system such a way that it is resilient to such disturbances, resilient such dynamic changes. So which is very, very important to really go forward with energy transition. Thank you. So the third one, as I told you, so what are innovations are required to handle such a to accommodate such a sudden load changes into the grid. And now there is a transformer technology. So what we have studied, there is a transformer, there is a core, some winding, insulation, some putting in the oil. But if you really want to control much smoother, we are introducing our electronics to the transformer so such a way that we can make a more good controllability and also more different designs. At the same time, should be the product should be biodegradable. So that is also one of the important, because adding only solar or wind is not enough to really achieve the net zero or a carbon neutral energy system. Because we need to control all the dimensions, because the transformers have a lot of installation material like oil. Those oils will also be very polluted. You can release into the earth. So to mitigate that, we are using different technologies, and also especially for the subsea transformers and floating transformers, floating substations requires a different design. So these designed as a transformer, which can be immersed into the almost pretty inside the sea, almost 3 kilometers depth of the sea. Still, you should work for 100 years. So that means that we need to really design such a unique design, such a way that you should be able to handle all the pressure acting on the transformer and its functionality. These transformers are specially designed for the offshore wind export, internet export, and also the oil export to society. And now, as you can see, all this, even now we are talking, people might study in the circuit breaker. Circuit breaker is nothing but a simple switch, but it should be required in an operating medium. The operating medium is an SF6, we call it SF6 circuit breaker. It is an air block circuit breaker. But if we are the first introduce a SF63 circuit breaker to the grid, because this requires a lot of research in the material, gas, etc. to eco-efficient circuit breaker, the transformer with the good efficiency, and also at the same time safety is important, and also the biodiversity. And also again, we want to transform this energy for a longer distance with less losses, we should use the HPDC technologies, etc. So these are all the innovations are already happening and it's continuously happening. But many researchers are working on it and companies are focused on it. Then now, with these changes, how our system is evolving. So a lot of changes are going through the power system. For example, this is what I think most of the times we see the power system is like, okay, one generation plant, with the load centers, maybe some residential transportation. But the transportation predominantly, which is the old transport, there is a only traction. But if you can see now, with the new scenarios, because then we are adding a different generation, the solar and also the thermal. At the same time, as I told you, more EV chargers, EV portfolio is adding. At the same time, it includes a lot of power quality issues. If you want to tackle power quality issues, again you need to deploy a lot of power responsibility to get the good controllability, to design the actual intervention. So it all makes the grid is more flexible, but at the same time, it poses a lot of operational challenges. As you know, we are measuring the grid, power grid performance with two key indices, like for example, reliability and stability. Whenever there is a disturbance, how the grid is reacting. Because if you don't have a stable, if you are not designing a stable power system, it will lead to the blackout. 2012, you might see, because of the improper design of the certain loads and interconnections, it may lead to the blackout. Almost like 2/3 of the Indian population don't have electricity for 2 days almost. So now, again, more and more renewable, more and more intermittent nature of sources are adding to the grid. It's required. Now we are redefining the concepts of the grid measurement index like reliable stability towards the flexibility and resilience. Means so the grid should be flexible enough because what happens, there is the inertia is going down. So we cannot predict wind, solar very accurately. Even if you predict, sometimes it's not available. So how really you want to balance your demand and generation? That is the biggest challenge. So for example, I want to show you some of the examples from the globe and also the Indian aspect as well. As you can see, the black ones, almost certain countries like Germany, Denmark, their instantaneous peak load even better than their demand from the renewable energy system. So then how do you really manage? Because what will happen because of that? You see here, a very simple example. This is for Indian perspective. We made the blue one, which is our normal demand. So that means that your generation has to follow the demand curve, such a way that the grid is balanced. But if you addition of the 2023, whatever we added almost around 200 gigawatt of renewable, the net demand is reduced. And by 2030, even that net demand even further reduced. So what do you mean in that? So if you can carefully observe this portion. You can carefully observe this. You see here. So what is happening is whenever the solar energy peak around afternoon time, you are producing more solar energy. So that you are compensating your electricity. So that in the evening, suddenly the solar is dropping at the same time. Your demand is also increasing because the electricity load is also picking up. Because of that, you see the efficiency of almost 40 gigawatt per hour. So how do we really achieve that? So that is the a key challenge in the power system. You understood? So you can see even take an example of Rajasthan. See, they suddenly dropping a 8 gigawatt hour in 2 hours of span. Then how to bring the plant up? What is available? So that's where we require a very advanced technology to handle these kind of situations. If you are not handling this, either you have to go for the load setting or you have to be otherwise it will be blackout. So what is important? So at least this is my personal view. So we can use 4 levels of flexibility to really handle that aspect. Only that the grids are now active. What is the meaning of active is that we are deploying a lot of power electrons into the grid, and that the advantage of those power electrons is that they are controllable. We can control very quickly, but how much and then what to control, how to control, and what are the parameters I can control. That's where this requires a lot of technology. A lot of technology means you need to get the data from all the loads, generations, and the central station. Then you can perform at the advanced development to really get that point. That's where what we are saying always, one is that we need to have an actuator. At the same time, the digitally is very important. Digital technologies are very important. Digital good communication systems, good data analytic concepts are really need to be applied to really handle such a system. So I want to show you one example how exactly they are doing it. I don't want to go to the deeper details, but somebody want it, you can discuss offline. But you see, the grid itself today, the inverter-based resources you can call. The inverter-based resources as a wind or solar system that is standard name now. So the inverters have a capability of different configurations. You can control your power very smoothly by changing this control, the grid forming, grid following, etc. And also we are connected to DC. Again, DC is another layer that is now getting power is really putting a lot of DC lines deployed. At the same time, there are stack devices, the stack pumps. The stack pumps are really designed only for reactive or control system, but nowadays we have a producing good batteries and also the super capacitors, etc. So what it does, whenever there is any bigger disturbance, it acts as a storage system that quickly controls that generation in a very fraction of time. So that the grid can still, even with the low inertia, but still it can be behaved like a normal grid. And again, we are coordinating with the, as I told you, the mobility, the industrial, etc. So everything should be controlled. Everything should be bringing to the control, control aspect, and again we can control what we need to control, then again we can change the right actuator. The actuators have the track devices, the actuators to the HVDC links, the actuators to make a use of demand, etc. So this is where the digitalization plays a crucial role. So in this, just I want to give a few three important applications in how we can leverage digitalization and what kind of benefits we can deliver in the power system. For example, many people might see the middle picture, technology called Hawkeye. So I am thinking, how many will watch cricket matches? Okay. So if you really see in the old days, many times, taking an LBW decision is very task for matter because we have to focus whether it is passing the line or not, again the height of the ball, again whether it is hitting the front first, back first, back first. It's very complex thing, taking in a woman and one person can track all these parameters in a fraction of a second. It's very hard. And so that is the reason we developed a technology called Hawkeye technology. Today we are seeing very simple. Just you can put these important signals in a different location, bring the data, apply good mathematics, and it will tell you whether this gadget is what the cost of different plans, then again, what is the height of the bus, everything we can just put it in the software. So, in similar even in football also, many times, goal and no goal, it's very tough to take decision. So, why not? We can use such technology of this, that this is very good, we can bring it up, because in our system, you see, you go for any of the substation, enormous amount of data is there, i.e. protection relation measuring data, nature for measuring data, and we have a very good communication system also available. Today we are applying even 5G technology, no need everywhere fiber technology. We can use the 5G to bring the data and we can analyze it. So, using that, we can do a much better thing, much more better aspect to combine all these technologies. So that, sort of good benefits we can bring it out using these digital technologies. So I want to give you a simple 3 examples. So, for example, you can see the transformer. The transformer is one of the costliest equipment in the substation, especially the high voltage transformer, because even it varies of tens of crores. So, the most of the transformer was, because we need to have a good monitoring, we need to identify what, to avoid this kind of failure, to identify the faults early, and we can take the transformer action. For example, as you can see, we have asset health monitoring system. It is a very simple system, but it requires multidisciplinary research required. For example, we have 1,000 transformers, you will get the data, offline, field test, or maybe maintenance, you can upload it to the database. Then you can use the expert knowledge, the expert knowledge, not the mathematical knowledge of the transformer. Then you can tell me what is the health of the transformer. So what is the issue? Like for example, okay, oil quality degrading or replacement degrading, or maybe winding have some kind of internal faults. So everything we can track it off. So, and also at the same time, you can learn from this way, you can apply mathematics, electrical knowledge, material science, and also the artificial intelligence. So we can correlate to the whole field and we can figure out what is the problem. So even recently, we have applied this technology in one of the utility in America, AEP. So they have thousands of transformers, almost 10,400 transformers, given around 8,000 transformers, etc. And we can really see the statistics. Many are 80% tell them, okay, this transformer will go die out of 1,000 transformers, these 5 transformers are much required the attention of other necessary. Such kind of knowledge this tool will provide. So I would like to share a short video about exactly what it is.
Over 3,500 substations, more than 5,500 power transformers, and more than 11,000 circuit to prevent failures? What can we do to optimize the maintenance effort that we have on the system? We've got more than 33% of our transformers, for example, are more than 50 years old. 1 in 6 are more than 60 years old. They're increasing in number, but as an aggregate, that asset base is aging. How can we best optimize and put our attention on the right things at the right time in the right place? The ideal situation is that we know everything about all of our assets at all times. And what it enables us to do is to know the condition and whether or not we need to do anything about it. And by the way, one of the important things about an asset health system would be to support decisions on what are the actions that are necessary. By organizing that information, it helps us see it in a much better fashion. We're not inundated with all of the data that we typically would be. So I think that's one of the greatest features that we're hoping for to support our operators. We're going to learn some things as we interact with asset health center. Our folks are on the phone almost daily with people to make sure that we understand one another, what's being expected, what's being delivered. We also believe that we can extend this to yet more assets and more facilities that will initially be able to tap into through real-time monitoring. That old infrastructure won't last forever. It probably won't all reach its end all in the same day, but it's important that we assess the condition of that aging infrastructure and take appropriate action before it takes the action itself and removes itself from service.
So another important aspect is that this is one application. Now you can see, I would like to show you a very simple application day by day. For example, a transform or anything what they do. There are distribution like that are going in and different of our home and small villages. A lot of trees will grow slowly and it will die. Then it may lead to the runoff, there is a line, we are seeing an outage. So then as a utility perspective, I have very limited money, but I want to prioritize which area I have to focus and use my care. So that is very, very difficult to identify, to optimize, because today the lot of pressure on the cost to develop. With a limited resource, we need to identify which area is going to be vulnerable, and again we have to take an decision. So that's called, we can call it as vegetation management. That's called vegetation management means, because this vegetation management is very, very important. Otherwise, especially in the Western countries, you might have heard in the news recently, California, a lot of wildfires. The wildfires will happen most of the time, actually, for the statistics. Most of the time, the proper vegetation, some trees touching the sun transmission line, and slowly it will develop the fire, and again it will be fire accident. So to prevent that, we introduce we require good vegetation management tool. So why I am showing this application for you, because this involves a lot of domains: communication, artificial, the computer science, again mathematician. So that's the important. So if you want to develop a solution, you should have a good collaboration among the different expertise people. So as you can see here, these are some kind of vegetation threats. How we can do? So we use either today we can use multiple sources of data. Either we can use video, images, especially today we are using satellite images. We can track this, there are every satellite images available. Based on satellite images, then based on images, we can predict how the trees are growing, which area is going to be vulnerable. So easily we can detect. For example, as you can see the total pollution. Then, for example, how we do that? These are the transmission that are going on. So these are the CCP area focus. Then also, then we can immediately
and prioritize your cut plans to prevent outages? These aren't impossible questions. You just need the right tools. Many utilities rely on helicopters, drones, and ground patrols, but the data is incomplete and disconnected. Introducing Hitachi Vegetation Manager, a closed-loop solution to predict and prevent vegetation threats. Hitachi Vegetation Manager includes a web-based back-office application, 2 native iOS field apps for ground and aerial patrol, and direct integration with Maxar's best-in-class satellites. Artificial intelligence analyzes satellite imagery, videos, and pictures, providing a single source of truth so utilities can predict risks and generate an optimal cut plan. The result? Fewer flights and truck rolls, lower costs and emissions. Keeping up with vegetation workload is tough. Extreme weather makes it even tougher and more essential. You've outgrown old vegetation management processes. It's time for a better way. For improved long-term reliability, resiliency, safety, and sustainability. Hitachi Vegetation Manager.
So finally, I won't take more time, another 5 to 10 minutes per day. More recently, because I'm leading this project from India, and these are what we from India, which is call locator. So what is the call locator? As you can see, the transmission lines are spread across the different geographical terrains. One line on an average for an area, 765 kV line, more or less 200 to 300 kilometers, even sometimes more than 600 kilometers. So whenever there is a fault, we need to identify the exact location. Then only we can send it to, then they can repair and restore the power supply machine. Even one of my friends is working on Indian power grid, especially in the northeastern region. Many times it takes almost 2 to 3 weeks to identify the location. Once they identify, we can put it off the wall. The remove the failed insulator, again remove the new insulator, even helicopter, but again they will travel the system, very difficult task. So but now it's a very critical and complex challenge. So I put a very challenge so that using the substation measurement, both sides voltage and current information, so that the communication technology provides that using that information, using the advanced technology, how exactly to import the location. So that means reduce your using the inspected multiple of like 50, 100 dollars, we are limited to only one of these area. That means that these two we can bring it down the way. So that's where the technology is involved as we develop. So I don't want to take into more mathematical details, but our start we are doing, you see, this is a transmission line, and both sides voltage and currents are available. From using the bridge formula, we can estimate the parameters of the transmission line. Then again, using the estimated parameters, then we can complete the picture directly. So this distance we can use for our application field engineers to go and take the transmission tower and they can repair and restore quickly. So this we have tested in our laboratory using the simulation, and after that, passing that, again we have done the artificial testing. Then I told them, this is giving 0.1% of the accuracy. I can locate this wall within 2,000 of distance. So even if I say, most of my own people are especially staying abroad, they are not doing something. It's not possible. It's impossible because they are trying from the last 3 decades to bring down to 1% of accuracy. But I am saying that 0.1%. So it is, I am getting, you can really see out of 2,200 cases, almost 76% of the cases are giving 0.1% accuracy. Means, what is the meaning of 0.1%? 0.1% is behind that. Just 200 kilometers, 200 kilometers. So that much accuracy we receive. But then, okay, let's go for the pilot. So the good thing is that today I really appreciate the Indian government and utilities. They really encourage to do a pilot called and this technology is located, you can see the ball is at 33 kilometers from station A, but this algorithm is big at 32.87 at that one time, 33.23, that means between 200 meters. So their expectation is that if we can do any ball locator, one particle means 2 kilometers is really good, but we are bringing down to 200 meters. That's the technology. Then after again, similarly proven even in the Sweden pilot, then we release this into the market. Then again, I will benchmark with the laboratory and field data. You see, most of the all these field cases again pointing out what exactly we are doing. So this is what I want to say that many times the technology acceptance takes more time, but we need to consistently work towards that and the goal was point. For example, what I'm playing water, on water. Whether I'm getting or not, that is not good. So we are getting now. So with this, even we are doing all the almost like now we are working for the 100 technology. So a lot of opportunities are there, even in India itself to do a fundamental research, to again, research to commercialize takes a lot of time, a lot of patience is required, and also a lot of collaboration. You have to come to this and you do the part, and a lot of people to collaborate, and you have to try, again, a lot of regulatory issues are there, again, legal issues, you have to, you are installing our devices, you have to method. That is what we do concept, we are doing. So then again, we are extended this thing with different aspects, like I told you. So mixed line, the overhead line, underground cable combination. There are a lot of new networks are coming up, and there are also this technology really working so well. As a whole, you can see the most of the existing technology, including our old technology, you can use. You need to inspect that on 30 to 40 towers. You really like the tower needs like this, very, very, very tough. These functions and going with difficult geograph terrain. So we see there again, even here power with helicopters to reach there and again, each way is difficult. So it takes a lot of time, but now we are limited to the number of times we need to do. So we do, and even the details are also normalizing so all the equipment goes to the customer, collaborate with the customer, and we go forward. That will make them understand how it's happening. So on this, I made a short video what about the technology to really understand the simple language.
Hello everyone, I am Dr. Odi Naidu, R&D Senior Principal Engineer at ICSSES. India is a cosmic nation that is progressing towards efficient surplus power supply. However, frequent power outages impact the people's quality of life. Quick distribution of the power supply is critical, especially in remote areas as it is difficult to reach. The challenge arises from the fact that until now, utility providers had a difficulty to pinpoint the location of the power in the grid. The teams have manually inspected the lines, find the location of the power. This was not only very heavier, expensive and time-consuming process on a long transmission line, but it also posed a risk to the lives of the utility personnel. To mitigate the above challenges, we developed an innovative, economical, secondary power-located technology for power transmission lines. Our solution can handle the complex power networks of the future. It results are 10 times more accurate than existing power-located technology in this industry. The solution is made available across all the protection devices with 1 kilo sampling hardware. The accuracy of the solution is comparable to the costlier power-located technology that uses 1,000 times higher sampling frequency. There is no need for additional hardware upgrade and communication bandwidth or complicated commissioning, engineering and settings. The solution is scalable to the complex power network. The power locator is adaptable and can enable the integration of greater resources to the grid like solar, wind, thereby contributing towards a sustainable energy future. With accurate power locator and outage management in place, India energy sector can fix the network cost efficiently and restore the power transmission line quickly. improve overall network availability and reliability, reduce repair and restoration costs by 8% from utility, consequently reduce the power bills for end customers, improve safety of the field staff, avoid high-cost patrolling methods like helicopter search and drone search, avoid unsafe crew patrolling, especially in difficult geographical terrain. With uninterrupted power supply, industries can boost their productivity while millions of people across India can enjoy an improved quality of life. So, thank you. So, what I want to conclude here is that, as I told you, so the national translation are working towards the net zero. It requires a multi-dimension, multidisciplinary collaboration are required to really achieve net zero. For example, you can see, you can focus on the environment while designing. For example, electrification, using both using natural resources like wind, solar to increase the energy, and also you design energy efficient equipment. For example, we need to create a lot of research on the material science side, and also eco-friendly portfolio. As I told you, for example, SF6 free technology to interrupt the currents. And also finally, you can see again the electric transport system are also good. But you want to integrate all these systems. Again, resilience is important. We require to have a good monitoring system. That's where communication technology, even good skills like artificial intelligence, that plays a crucial role in combining all these disciplines. But now we are doing all these systems. You are doing more and more digitalization. Again, at the same time, we get into a lot of cyber attacks, etc. As you can see, I don't know whether people are read the demand or not. See, I have seen recently, very interestingly, any war is started. For example, taking a Russia-Ukraine war. In the first day of the war, everybody, they had to attack their property. Then they destroy the power system. Automatically, most of your things are gone. Especially Western countries, they're really depending on the power systems, including, otherwise, the temperatures are very low and their cooking is also mostly depending on the electricity. So that is the reason the good cyber security is also very, very important. That's where I'm telling, so you combine all these technologies together, only we can really achieve towards the net zero. So this is my final slide. If you really want to achieve this, the energy transition is a very, very big problem. It requires a lot of partnerships. So towards these kind of concepts, and also it requires a lot of good collaborations among the different domains. That's where I really like this conference, which is really, really connecting, smart systems for electrical sciences. That means that it is really connecting all the dots, communication, good instrumentation. Then again, the computer science will make a smarter systems, which is very, very important. So that's what I would like to say. If you really want to achieve the energy transition, again, you have to focus on the designing the sustainable products and solutions, power electronics, and again, at the same time, digitalization. So these are the important things to really achieve the net zero for any of the country. So thank you so much for giving us this opportunity to share my overview. But these are like very high level view. But somebody really want to know the deep details on any of the topic, feel free to contact me anytime through your professors. Thank you so much, sir.
Thank you very much, sir. for your enlightening words on energy requirements and demand by 2050, renewable energy capacity, growth, and new environments, and so much more. I'm certain that the audience has gained valuable insights from your words.
I now invite Shri T.K. Nanjundappa Sir, Secretary, SSES, Dr. Shukumar Sir, Joint Secretary, SSES and CEO, SIA, and Dr. S.P.K. Sir, Principal, SIA, the President, Chief Guest of today's event, Dr. O.P. Naidu Sir.
Madam side.
Thank you all.
Now I invite Ms. Brunda Hess from ECE for the introduction of our guest, Dr. Madhusudan CS Sir.
Good morning. Good morning. Good morning, everyone. Dr. C.S. Madhusudan, presently serving as a Group Director at the Professor U.R. Rao Satellite Center, where he is responsible for program planning and execution at the center's activities. He has over 34 years of experience in spacecraft power system, including the design and development of power electronic systems, test automation, system optimization, design for manufacturability, and capacity building. He has been instrumental in the end-to-end realization of various spacecraft avionics such as magnetic torques, OBC, DC-to-DC converters, distribution systems, array shunt regulators, battery interface modules, FPGA-based central power control packages, telemetry packages, RF systems, and relay modules. He has served as Deputy Project Director for several LEO and GEO spacecraft missions, including Chandrayaan-2, Indian Microsatellite 1, GSAT-4, and GSAT-8. As Group Director of Systems Engineering, his notable achievements include the realization of 26 avionics for Aditya L1, approximately 50 avionic hardware for SpaceX, and about 75 avionic packages for Chandrayaan-3. He holds a bachelor's degree in instrumentation engineering from SIT, MTech in electronics design and technology from IISc Bengaluru, MTech in computer science from National Institute of Electronics and Information Technology. He holds a PhD and MBA with a focus on finance and production management. He has published over 25 papers in national and international journals and conferences, holds 3 patents in spacecraft avionics, and has guided approximately 40 students at the graduate, postgraduate, and doctoral levels. He is the author of the book Advanced Power Control Management for Spacecraft. He is a life member of ASI, an International Microelectronics and Packaging Society, and a senior member of IEEE and a fellow IETE. He received the Team Excellence Award for the success of Indian Microsatellite 1 and recognized as the most eminent scientist during Engineers Day 2023. We are privileged to have Dr. C.S. Madhusudan with us today. We look forward to his valuable insights. Thank you.
Thank you, Brunda, for the introduction. May I now request Dr. Madhusudan CS Sir to release the department's newsletters.
ICO from ECE, Livewire from EEE,
Tatva from EIE and Teleblitz from ETE. Thank you, sir, for releasing the department's newsletters.
Now, I request Dr. Madhusudan CS Sir to present the keynote address.
Good afternoon, all of you. Good morning, all of you. At the outset, I submit my respectful pranams at the lotus feet of His Holiness Dr. Sri Sri Shivakumara Mahaswamigalu, Founder President SSES, and Sri Sri Siddhalinga Swamigalu, President SSES, and I seek their divine blessing before starting my keynote address. Other dignitaries, Sri T.K. Nanjundappa Sir, Secretary SSES, Dr. Shivakumaraya, Joint Secretary SSES, and CEO SIT Tumkur, and Dr. Odi Naidu, who has done a wonderful lecture, who happens to be from Hitachi Engineering Research, and Principal Dr. S.V. Dinesh, who has been at the forefront of educational, industrial interfaces and research advancement at SIT, Professor Rashmi, another coordinator, and Kalpana, and moreover, my dear students. We'll go for the next one. Can you come for the first slide? Actually, I wanted to give a lecture on space challenges, but seeing this kind of audience and seeing that kind of earlier feedback what I got, I changed the topic itself. The topic has to be in the advanced technology satellite field, which I am going to cover on. Before starting anything, before doing anything, first we should know where we are, what we are doing, and what part of we are going to constitute. Otherwise, what happens, we say, I am doing, only will be telling us. This is case we are seeing everywhere, education institution, organization, research, everywhere this is seen. So, first of all, you see, what do you say, I have got, let's say, where are you staying? If you say, somebody else, you say, I am staying in a good house. Okay, what is the dimension, 30, 40? Or, okay, I am rich fellow, I am got 60, 40 site, doesn't matter. Subsequently, what? What is next? A road is consisting of a number of, let's say, these houses, 10, 15. Then many of these streets are going to ultimately form one layout. We'll be having so many, what is next? Then we'll be having so many layouts coming under a particular ward. This much only? No. Then these many layouts are going to ultimately form one ward. Okay, this can be end so that I can feel that myself is a very comfortable position, I am doing very well. No. This is going to be that many such wards are going to make your taluka, or you can say your city for that matter. Subsequently comes taluka. Next comes a district. Okay, we'll confine here only. No, we can't confine here. What else we have to go? Where else we have to go? There's a question comes. Correct, no? Next you say, okay, we'll limit to the district, then you go to Karnataka. If you say Karnataka, now roughly it has got about 1.9 lakh square kilometers. This is the area of Karnataka. Okay, this is the reference for easy to consume, correct, no? Can you stop here only? No, we cannot stop. We have to go to India. India is roughly about 45 lakh, it is about 30 lakh square kilometers. Okay, a good idea figure we have got, fine, we can stop here. What is next then actually? You take the world. World has nearly about 501 lakh square kilometers. I think this is the one what we can imagine, what we can assimilate, will end here only. No, we cannot end here actually. Earth is one of the planet in our planetary system. This planetary system only is called a solar system, correct now? Somehow that 9 planets has become 8 planets because of dwarf planet, all those things are there. Finally, ultimately, if you see, where are we? We are just a planet only. In that, where are we? Correct now? Okay, this somehow I couldn't understand. I can once in a while I see that one ISRO sending some missions to Mars, Venus is planned. Okay, something we can think. We cannot end here actually. There are about 3,200 this kind of planetary system in our galaxy itself. Then where are we? Okay. In Milky Way itself there are so many things. Okay, at least can we end it here? We cannot end it here. Because there are about 100 billion galaxies in this universe. Then where are we? What we think? We started from a 30-40 or 60-40 house, we went to the road, we went to the street, we went to the layout, we went to the taluk, we went to the town, we went to district, we went to the nation, we went to the world, we went to the galaxy, we went to the universe. Where are we? We represent a very, very minuscule of the whole world, whole universe. This is, one case is a philosophical point to be pondered by seniors like us, whereas juniors like you, a student like you, it is really a astronomical wonder for you actually. This is the point you should start. I represent a very small thing. Whatever I will do is actually should be a bigger one to contribute for the whole universe. Next one, please. See, as I told, this is actually what I was trying to represent through my earlier speech, that This is the one which is going to represent the whole thing. We are a small, minuscule part of it. Okay. Next one. Toward this, what is the contribution of ISRO? How much we can contribute? If you all this can see, we have launched till now about 131 satellites. Not 1 or 2 or 10 or 100. 131 satellites. The satellites, no, they are categorized based on either on the mass or based on the power. Correct. See what happens if you take a mass as the reference, we got a nano satellite weighing below 10 kg to the big satellite GSAT-11 going up to 5,400 kilograms. Okay. And taking it to the power, you will take the very first satellite of Aditya. I will take Aryabhatta for that purpose. Aryabhatta had a power generation of 46 watts only, which was launched in 19th of April 1975. Today we have got satellites giving up to the 14 kilowatts of power. If you say now what is this one, how to get a feeling of it? If you take your mobile phone, it has got internally 3.7 volts or 4 volts battery. Basically lithium-ion will give 4 volts only. Whatever the technology will give 4 volts only. Correct. Now, if you pass 1 ampere, it becomes 4 watt. It can do a lot of function. Next is you can computer. It may take nearly about 25 watts doing so much functionality. Next you can go for your TV, having an Android connection and all, going for 75 watts. This is the power. You can see something if you are beaming from the space, it should have so much power. Once you have higher power means we can do more function. That's the simplest point of it. And you can see that one, NVS-02, a navigation satellite launched in 29th of last, means January 2025, it became the 100 launch from our spaceport Sriharikota. That is the one covering most of the things for Indian satellites, but it had a coverage of other satellites also, other country satellites also. Next we can see the centuries are not just hit by Sachin Tendulkar or Virat Kohli. We also hit a century. In 2017, February 15, launch happened. We launched about 103 satellites in a single go, which is the world record then and remains now also the launch of 103 satellites in a single go. If you take that as a reference, today we have launched about 430 plus satellites, including foreign satellites, student satellites from different countries. How we can make this one possible? Can we launch satellite ourselves only to the space? Not possible, because it has to meet so many laws to become a satellite for the Earth. What are this one? We require a launch vehicle for this one. As we can see right side, this is the PSLV launch complex, first launch pad, what we call. This is the rocket, what you can see is PSLV. Generally, it can carry up to as on day 1.8 ton for LEO orbit. LEO orbit means low Earth orbit or synchronous orbit. And it can carry up to 1.4 tons of satellite for geosynchronous orbit, what is used for basically communication purposes. Okay. And other one is the second launch pad where we have got the bigger rocket called a geosynchronous. As the name it signifies, it is meant for launching geosynchronous satellites. Okay, this has got a capability of up to 10 ton to launch to the low Earth orbit and 4 ton for LEO orbit, geo orbit. And this is the one which has launched our Chandrayaan-3, making the history on 23rd of August 2023. And one more launch pad also is going to come very soon in Tamil Nadu, and which will be hosting the launch of one more point we can ask. These are things you are telling so much of satellite and all. I make a small satellite. I make a satellite which has got less functionality. I will not be able to afford to have a bigger launch. What I should do? Correct, no? In such a case, we got one more launch vehicle called as launch vehicle on demand. Whenever you want launch vehicle services, certainly we can go for SSLV, which can take up to 500 kilogram of satellites, not really have to waiting for piggyback on a big satellite, bigger launcher vehicle. Okay, this is like when you say you got a big truck, lorry you got, and you got a ACER vehicle, ACE vehicle, certainly it is a requirement of the people actually, that we have to serve it actually. Now, I was telling the starting only, we have launched different satellites for various applications. We will take one by one actually, in simple terms only. I will not take much time at all. Earth observation. What is cartography? You would have heard the name Cartosat series and all. Cartosat 2A, Cartosat 1A, Cartosat 3, Cartosat 3A. This basically meant for mapping the geographical area. Mapping the geographical area. Certainly, this is what I was discussing with our Dinesh, our principals are also that one. How this has helped in making the smart cities. Smart cities means what? We should have power, we should have road, we should have infrastructure, we should have good convenience, and of course we should have good network of backbone network. So all this only constitute ultimately a smart city. For this one, what is required? For this, what is required is that one, we require a very good planning. This cartography is the one which is going to help in making such things and all. Today, now, earlierly when we launched the IRS-1 satellites about 2.5 decades back and all, it had a resolution of 40 meters. Means to say, from space, I can distinguish an object on the ground which is about 40 meter in profile in size actually. But as the day progressed, either because of strategic requirements or because of our planning requirement, town planning requirement, or for the crop estimation, things have got changed dramatically. And today, you may wonder that we can identify an object which is as low as 0.28 meter from the sky. Tomorrow, don't be surprised if you are booked for your vehicle offences based on an image taken from a satellite. Okay. Disaster management. Disaster management was, see, there are so many disasters happening, cyclone happening, and again landsliding. One of the real things which we captured in the last year was we had a Wayanad disaster, you would have seen actually. So what happens, some time, no, better imaging can happen with the sunlit or sun condition, but this may not be the case always. So what we have got satellite called a synthetic aperture radar satellite, which can take the images in under the all weather conditions. Okay. So what happened, we have got a nice image from our RSAT satellite and earlier Cartosat, we compared with this one to give a quick note of how much was the landslide happened in this one. Correct? And satellite communication is the most important thing. See what happens now, when you say if you are in a room, you want to contact your near or dear ones, when you make a call, it will not go. What will you do? You will go out of room. Okay? Then you will go to corridor, there also will not get it. You will go to your outside the street and all, they also may not get. Suppose if you go to some, let's say, a lonely area, if it is surrounded by hills, there also you may not get it. Ultimately, how do you reach? The point of sight is the one which is the most important thing. As you draw a different lines from your different points, ultimately you reach a higher point where you can communicate to all people. That's only called as satellite actually. So satellite is effectively used for communication, especially it is useful for your offshore. If you say Iridium 66, anybody heard of here? Iridium 66? Anybody? Iridium 66 is a configuration made by Motorola to make worldwide communication. You are in the hill, you are in the northeastern region, if you are in the deep canal or in the sea, you will be getting communication all the time. This is the wonder of the system. And of course, broadcasting, you are aware, DTHS and DSNG. And tele-education. If you have read, I think, Deccan Herald, June 7, of course, it cannot be for this year, it is from earlier year. They mentioned that in engineering colleges, there is a vacancy of up to engineering as well as other educational requirements, 1.26 lakhs of teachers, there is a deficiency they mentioned actually. See what is happening, either they may not be having a professional qualification or that institution may not be able to afford them or specialization may not be there. So all these things, solution is tele-education. We launched a satellite earlier called as EduSat, purposely meant for this objective only, to usher in the propaganda of education throughout India. This is going to beam the lectures live across throughout the country, so that the people who are disadvantaged can listen to this one. Next, you think of, let's say that if you are in a place and you need some kind of medical support. Even if you take Tumkur also, it may be difficult to get a good heart surgeon, I don't know. But everybody is concentrated in Bangalore only actually. But if you, one more thing they say, anything happens means you should come within half an hour, golden hour, you should come to hospital. How the golden hour in the traffic you reach the hospital? My Baswangudi, I cannot go to Manipal hospital in 1.5 hours. How anybody can reach from Tumkur to Bangalore, Bangalore to Manipal hospital? Correct, no? So what happened? The telemedicine. Telemedicine means See, regionally we can think some hub is there in Bangalore. We will be having the recipient, that is actually that some medical unit requiring this kind of services in the distance area, and the expert hub and the recipient node. All this going to form with the satellite link as telemedicine hub. This is going to give the required services for this one. Navigation is the most important thing. Correct now? Today, how you are getting your route map and maps, what at Google, how you are getting? Any idea? Huh? Through which satellite you are getting? Internet is okay. Which satellite? See, generally now, whatever satellite is used to called as GPS satellites. These GPS satellites are from US military. They are giving this kind of services for other users to make use and build their applications under. And this is an uncommitted service. Okay. Anytime anything we'll ask this question, no, what is the India's answer? What is the India's solution for this one? Correct, no? So we have made our own navigation system. The fleet consisting of 7 satellites which can give the information regarding the navigation throughout in India and as well as in the Indian region also. You should note this one. Indian region means in and around India also. This is going to help in aviation, marine, transportation and agriculture. Aviation, have you heard of Gagan services? See, Gagan means what? Airport of Authority of India for signaling and takeoff. They want accurate information regarding the location. Today, whatever you get from GPS is not so accurate. If you put from my house, I will get the next road. If I go to my kitchen, it will come to back road actually. Why it is happening? Any idea? Same house only. If I am giving from my hall, it is coming to the previous road. The kitchen means it is going to back road actually. The reason is that this have got only 5-meter resolution. Okay. 5-meter resolution means what? Depending on the nearest, it is going to show the available point. Okay. This is not okay for aviation sector. So what happened? We have got a Gagan services which is going to draw that the corrections required in the atmosphere to give a very good information regarding the landing of this one. Okay. And of course, we got many astronomy research, planetary exploration like our Mars Orbiter mission and again Venus Express and so many missions which are going to come in the future. Next one, please. See, this was I was explaining the morning to somebody else. See, the most difficult, see, you can see the space demand I have put and challenges I have put. Demand means actually what I want, you are demanding this one. For demanding this one means I have to meet so many challenges. Okay, now, what are the demands you seek? Demand requires hostile space environment. Hostile means what? You can see that one. Today in the Earth atmosphere, you are going to measure the pressure in bars. Correct? And Kiranmai is she is expert in instrumentation also. Correct. But what happens as you go up in the sky? You may see that one will go up to 10 to the power of minus 5 or 10 to the power of minus 6 tar, not bar. You should remember. Tar means is a smaller unit. 1000 tars are going to make 1 bar. Then you can think such a hostile environment means is equal to is a hard vacuum. It is called in the hard vacuum in space jargon. In the hard vacuum, the systems have to work. What are the implications? Secondary breakdown, thermal runaway. These are things what you are going to give. And system availability is the most important. If you make a satellite, if you say I will not be able to operate the stock market today because the satellite is not available, who is going to accept it? Correct? No. It has to be system available. The word used for continuous service is system availability. And of course, no, depending on the satellite orbit, you will not be able to see the satellite in all the orbits. Okay. Then what will happen? Certainly we should go for some kind of autonomous operations so that we can make the operation autonomous irrespective of your orbits. Okay. And of course, it requires expertise or special skill sets for this one. And of course, one of the most important thing is which hallmark that space technology is the state-of-the-art fabrication and test capabilities are required. And the design tools for design analysis, like for example, if you make a system design, power integrity, signal interfaces, ICD documents, all those becomes most important. And the highest quality and reliability. See, this quality and reliability, now somehow it has been used interchangeably used. Anywhere you say, either you have got good quality, only they will ask. Some cases, reliability is good, they will ask. What is the difference between these two things? Both looks alike only, no? Right? Reliability and quality. We majorly depend upon reliability for our space systems. The why? In tech, quality of a product depends on the material, depends on the process, depends on the inspection, it is going to come out. Means this is going to be at time t is equal to 0. T is equal to 0 means as on today. But this is not sufficient for me. Having explained so many things, I want it to happen working with the required conditions to the end of the satellite life, UOL, what you call end of life. So it requires reliability. Reliability means in simple terms is quality over time is called reliability with the stated accuracy of operation. What challenges we face? Changing user demands. Payloads are demand. You say today we want to put ham radio. I think SAT can also just slip into this particular ham also. We got a satellite meant for ham actually. Okay. Then the requirement is changing. DTH we got communication, we got navigation, we got geoimaging. It is going on changing actually. And next thing is mission planning and execution is the most important thing because of the complex mission what we encounter. Next thing is advanced technologies. No, this is the one we should never miss out on this one. You should take all the opportunities to rope in advanced technologies to become relevant in the particular field. And mass and volume constraint. In our Vodi Naidu has explained beautifully. Two things he told. That is one is Ukraine and Russia war. Actually, one more thing actually there. This war has led to energy crisis in Germany as well as in UK also. They could not meet the energy requirement of those countries and all because of the outcome of this one. Second thing he explained about the transformers working deep, 4 kilometer deep in the sea, and how do they operate and all, how to take care of the future and all, and going for switching type of transformer, not going for this one actually. Right. And again he told that one how to harness the power from tidal, then again going for wind energy, then going for solar and all actually. But if you see all these things, and he also told that one Bombay requires 1 gigawatt power in the coming days, like that also he told. But if you sum up and tell, today what is the cost of 1 unit? What is the cost? If you say energy meter is there, no. In energy meter, if you see 1 unit is means what? 1 kilowatt hour. What is the cost? 5 rupees? Don't say it is free of cost. Okay. Free of cost is not the answer actually. Okay. Generally what you can say for domestic is 1 kilowatt hour is equal to 10 rupees you can take. Correct? Okay. But what would be the cost in satellite? So many points are listed here. No, mass and volume constraint I put actually. That's the reason actually. What is the guess? How it would be? Because everything is the solar panel we launched, battery also we launched, everything is launched. So everything is available. What is the cost? You may wonder it may go up to 10,000 rupees per unit. Then you can see make a satellite generating the power of 14 kilowatts power, operating 24/7. 24/7, this is really 24/7 only, not like people telling, no, I'm available 24/7, anytime you can contact me, they say. Contact, if you can't, they'll be phone switch it off only, always actually. This is real 24/7, operating for nearly 15-16 years, and giving this one, you can calculate what is the cost involved in this one. So much of energy we generate, we have to pay so much. That's why it becomes so much critical. I add one more dimension to Mr. Naidu, which is telling about the terrestrial. This is the one more dimension you can take up also actually. Okay. Next is coming to mass. Okay, now what is the mass? Why really mass matters in a satellite system? What is the problem actually? Correct now. Anyhow, you are launching rocket is taking its launch. What is the real problem in this one? Real problem is in the economy of launching of a satellite. What is the economy? See, for launching 1 kilogram of satellite, it requires $20,000 US. Okay, then what would be this one? Cost, if you have to make about 2 tons of satellite, then what would be? Then you can imagine. So this is the kind of thing what is encountered this one. That's why these two are become the constraint for our operations, our design. Next one, please. This is the one which made history. See, generally now you can see in paper. Okay, first I'll explain this one. Mission objective was to make a safe and soft landing, a rover roving on the moon surface, in situ scientific experiment. It had 3 modules. One is propulsion module, mass about 2.2 ton and power is about 758 watts. And second is a lander module. Its mass is 1.8 ton and power was 738 watts. And this is actually meant for lunar day. One lunar day is equal to how many hours? Any idea? How many days? Are same as the day of our India, our on the earth. Huh? Any idea how many days did this lander lived? As per the lived means of the communication only is taken as reference. Not it is physically there only, but communication, if you take how many days it could send the messages back to the earth. See, lunar day is same as your lunar calendar. So what happens? Amma was say starting this one, no? First to 14. So it has got 14 days only actually. Padya, Bidige, Tadige, Chauthi, Panchami. So 14 days is the lunar. It lived up to 14 days on this one actually. So that's the one. And it has got scientific instruments, 3 on the lander, 2 on the rover, and propulsion module, 1 as one. See, always you see that one, no? Any technology we make, ground means we are in the nth actually. We are not the first, not even second, not even third, not even 10th, we are ground nth number only. In satellite and technology, in the SpaceX, undocking has happened and docking has happened. It was told in the paper, now we became the 4th country in the world to make this, achieve this feat and all. Then you can achieve. Why always 4th, 3rd only? I want to come first on the podium and stand in the center of the stand. Yes, we have done this actually. We are the first country in the world to launch Chandrayaan on the south pole of Moon. No other country has done till now actually. There's a historic reason also for this one. People used to land or send the missions to the other areas of this one because it is easy to access, easy to see, easy to communicate. But our hunch feeling also was that towards the pole you go, there's a possibility of water is more and more. When you want to colonize moon, certainly you require water is the most important thing. That's the reason that it has been tried and successful in this one. Next one, please. And this is the most important question. Why we have to study sun? Correct? And daily we are morning 6 o'clock to evening 6 o'clock we are seeing sun only. Enough sun I have seen. It remained same only since I was childhood of 2 years to for 50 years it is remaining same only. Correct? No? Everything is the same only. Why should study actually? But youngsters may wonder that already 50% of the sun's life is already over. What do you say on this one? 50% life of the sun is already over. But you do not worry so much because sun's life is 10 billion years. 1 million is equal to 10 lakhs. 1 billion is equal to 100 crore. Then life of sun is equal to 10 billion. Okay. But already 5 billion is over. We are getting this light, temperature and photon because of the continuous fusion happening in the sun. Okay. But it also gives some kind of corona ejection it gives. So what you can see, solar wind properties, coronal heating and solar wind acceleration, coronal mass ejection is the most important CME thing which is going to happen, and dynamics of solar atmosphere. So these are the important things we should study. That's why this Aditya L1 was launched. Next one, please. See, you would have heard this L1. Many people ask me this question, what is called L1? You generally, we say Chandrayaan 1, Chandrayaan 2, Chandrayaan 3. GSAT 1, GSAT 2, GSAT 3. Why do you call L1 actually? It is called a Lagrangian point. See what happens now, anytime, anywhere you place, you should have 2 requirements. we should be able to see the particular object of study in a continuous view. Second thing, we should require less fuel for maintenance in the orbit. Okay. There are about 5 points you can see here right side, L1, L2, L3, L4 and L5. We chose L1 because it is 15 lakh kilometer from the Earth. How many kilometer? 15 lakh kilometer from the Earth. But however, this is the point where it requires a minimum energy for holding on to this one, and as well as to see the scene directly. Because when you send a satellite, sometime you would have seen actually, because of sun outages, you can say. Sun outage means what actually? The solar flares have made many systems dysfunctional in the satellite onboard space radar, because this contains proton rays, electron rays and cosmic rays. These are the one which can affect the electronic component, especially CMOS component. Complementary MOS circuits, so they can get easily on this one and make the system to go single event latch and single event upset. These are the words people should remember. Next one please. Whenever you find time, or whenever you happen to be having free time and all, no, where will you go generally? Ajji mane, atte mane, or okay, you can say, okay, I'll go across this one, I'll go to Bombay, I'll go to Calcutta, that sort of thing. Why can't you go much bigger than this one? Correct now? Times are not too far away when you hear that people say, today I gone to space and come back like that. Today I gone to space and come back. The reason is that thing is advancing in such a speed. If you remember in the mid-90s, perhaps except Naidu, I think other people will be aware, the JTM came to Bengaluru. No? This is the first mobile operator came. Film star Srinath used to come. I have become JTM. Have you not become JTM, used to ask. Okay. We could not become JTM that time because outgoing call was 24 rupees and receiving call was 12 rupees actually. He was only in JTM, I think. The reason for this one, as the time progresses, no, when the mass production happens, the cost will come down. Today you can take even the laptops. Laptop price has been essentially remained the same only since I graduated after from SIT till now. 50,000, 60,000 rupees, you can get decent laptop, if not very good laptop. The prices remain. This because we have got very good production which is going to control the prices of this one. Similarly, you can see Gaganyaan also. Today there are 3 or 4 companies already offering trip to space. Virgin Galactic, you would have heard of Virgin Atlantic Airlines, somebody would have heard. Virgin Galactic is there. Then Boeing is offering. SpaceX is offering. But what is the cost? It is not like you are going to relatives, uncle or aunt's house. Okay. Anybody has got any assumption or some guess on this one? See, for going and touching space and coming back, you should listen the word. Going and touching the space and coming back, Virgin Atlantic is offering at a price of 3.75 crore rupees. You can buy a palatial house in Tumkur, I think. Right now. If you go further, one person from Andhra origin, he went to space. Name anybody aware? He went to space and came. He made a study. He paid around 200 crore rupees to go to space and come back. And people estimate when in future I'm telling, not now, nothing is now. In future, if you have to make a mission to moon, it may cost somewhere around 800 crore rupees. Okay, these are the things happening. You should know what is happening in the world. That's the reason I'm trying to put this point. You can see that one here, the Gaganyaan is one actually mission. Our aim is to launch human to space successfully and bring them up back to Earth after the mission completion. The whole idea is to this one only. Already we have launched our test vehicle one on this one. It successfully has come back, and many abort mission also we are taking. Abort mission means suppose in case something happens during the takeoff itself or during the in-between, how to secure the astronauts. This is the point which is the most important thing. Already we have taken some action on this one, and we got many abort missions coming on this one also. And you can see in the, maybe in the media or paper or in the TVs that maybe in the coming months you'll be seeing our unmanned flight. Earlier called unmanned, is become now Gaganyaan Jeevan. Gaganyaan Jeevan soaring to the skies in very soon actually. That is, gives you idea that one, how it is going to be there actually. Initially we are going to send the humanoid to space, subsequently human will be sent. Next one please. Next one please. I told you, no, I changed my topic yesterday only because of seeing the first of all, the kind of audience here. They're supposed to be from, let's say, from different colleges, different institutions, as well as I should try to give some more and more inputs on the technologies happening and all. That's why I changed the topic. You can see that one, emerging trends in space sector, small satellites and small constellation, and AI and ML based technologies, and digital beamforming, and secured communication. See, secured communication, when I meet our VTU Vice Chancellor Vidya Shankar ji in one of our BEL symposium conference, he was telling me that one. See, recently I got a message from ICSSES Bank saying that one, 29,000 rupees has been deducted. If you have not done, you press this key like that. He said he pressed, and obviously what is have happened is happened actually. He was telling, I was doubting why to press or not, but still I pressed because that 50,000 rupees is the one actually what that he has set the limit for ICSSES to give that message for when the transaction happening and all. A lower amount has happened, but he could not suspect and he pressed. So he was telling how to avoid this one, he was telling, and one more question he was asking, how do you take it in satellite also? So there are different ways. Frequency hopping is there, change the frequency, going on changing the frequency, hop the frequency between S band and KU band. Maybe communication people will be knowing all those things and all, in at least the band, if not the hopping and all. That's how we should take. And IoT and digital twins for satellite. Next one, please. See, this is the one we should see, the most first point actually. Earlier, now we used to launch big satellites only. Earlier, we used to launch big satellite only. Now, the small has become beautiful now. And second thing is that the losses what we incur in case of any catastrophe or failure happening in a big satellite, it is going to be huge. Today, if you have to make a medium-sized big satellite, it may cost around 400 to 500 crore rupees. If you say some glitch happens, some malfunction happens, then what is the loss? It's a huge company itself can be swiped off actually. Correct? No? So what happened? We are going for small satellite. If you have to give some example at what I earlier told, our IRS-1E satellite which we made in the around 2000 beginning or 1999 had about 1 ton of weight. It had given that required all the applications and all what a remote sensing satellite would require, and it was weighing about 1 ton. And subsequently in last decade we have made one satellite called as IMS-1, Indian micro satellite number 1. That was weighing 100 kg only, mimicking the function of this one. So what happened? Because of technology, because of putting more and more packaging, we are able to achieve the higher density as well as the functionality what otherwise would have got from a bigger satellite. Okay, na? Certainly constellation of satellite, you would have heard the word some of the words like buzzword. What are the buzzword? Constellation of satellite. Iridium, I told example, Iridium 66 is called as constellation of satellite. Next, when it came from the big satellites, when it come to some small satellites, it was called as shoal of birds. Means to say, the smaller one, the large number. Okay, na? Now it is called swarm of bees. Nano satellites which is weighing less than 10 kg, putting a large number for communication, it is called swarm of bees. So all these things are happening because of industrial manufacturing and mass production happening in this one. I am taking more time or what? Huh? Okay, next one. See, this one slide I purposely have put this one because this question is asked by different people also. Where all I can contribute? Correct, no? I am not in a position to make a satellite. I mean, I am not in a position to make one bigger experiment where I can contribute. This is going to give entire the gamut of activities in the supply chain management for systems manufacturing. I have taken the example of avionics system manufacturing. When a requirement comes to us for satellite, first of all, the application, what is the purpose of satellite we are going to get? that we are going to deduce and make the specification for satellite. Okay, that's coming under planning activities. Next thing what happens, we further deduce this into plan of action. Okay, and this is a continuous process which is going to happen so that we achieve the best configuration at the best schedule possible. Okay, but what happens, the supply chain is one of the most important difficult thing here, because today also we can see most of the triple E components. What are triple E components, madam? Any idea? Triple E means electrical, electronics and electromechanical components. Okay, this acronym does triple E components. These triple E components manufacturing in India is a difficult one. Still now we are not able to get. But however, many other components we are equivalents we are getting the LSI ICs we are getting, MSI ICs we are getting, but not able to get that FPGAs, not able to get processor, not able to get microcontrollers, of course, are these triple E components. Certainly, that's why I showed that one here indicating that one, these components like international rectifiers are put, we have to get from abroad sources. This will do. But however, lot of things we make here. What we make here? Mechanical housing, titanium rings, studs, bolts, and again some of the components which are indigenous age, like flute F wires, then again the different kind of connectors, all we are getting in-house only. These we can put them together to assemble them and make a product. Okay, now when you make a product, the space system, no, the backup is the most important thing, because getting the components, subsequently storing them and using is the most important. For that we should have a good warehouse for called as ESD compliant bonded stores. We call bonded stores to hold these components, and as well as the packaging systems. And delivery shall happen for the different systems on demand, actually, on demand. Subsequently we do production analysis saying that one, this could have been done much earlier. We could have made, the requirements are coming seamlessly. I could have planned for the more components in the large number, where I could have counted some discount also. So all this analysis we can do subsequently. So as a entrepreneur, as an individual, how I can contribute, you can see that one, that you can whole gamut of activities, you can be participative in this one. Next, the door closed now. See, you would have heard, morning also we are discussing that why we are giving a TDP and R&D to academia. You would have seen already we are so much busy in our flagship satellite projects under regular communication requirements, Government of India requirements and all. Certainly, we would require the help, assistance or input from the academia. That's the reason we are offering this TDP and R&D to academia. You would see that when the host of TDP were put in the Respond website actually. Now this time I see that SAT many have applied for these proposals have been given, but this is the one actually. We want people to come and do it actually, that's the reason. Okay, this is the whole thing. We can see that one, either you can be a supplier, you can be an assembler, you can be a fabricator, you can manufacturer, or if you are academia, you can say I can do simulation. Okay, I can do analysis, I can do what you call as signal integrity checks, I can do power integrity checks. So all these things are possible here actually. Okay, so this is a place where you can contribute based on your capabilities. Next one. Next one. So here only now this industry now technologies are becoming most important. Industries will provide technology for us wherever it required. I'm telling you, wherever required actually. Otherwise we got our technology, industry will give technology wherever they required. Academia we want from the TDP and R&D. Next one please. See this, we can see that one application of AI, you can see in the all applications. See how to produce the hardware also is clearly mentioned. When you have to produce in a large number, certainly we cannot go for this through hole kind of base designs, which will take large amount of time, as well as mistakes are more. From this point of view, we will make convert all the components required for into surface mount technology component and board, put them and print them together. This is all the technology what is possible. And actually what happens on satellite system, the gain fixing, controllability, controlling and amplification, all things are going to come subsequently. Certainly we require that human interaction means tend to create so many issues. One is accessibility of the points. How do we put the components? How do you solder the components? Okay. So certainly robotic arms are the one which is going to help on this one. Next thing is, when you make the systems ready, who is going to check this one? People. people have got their own limitation, fatigue factor, knowledge, inputs, all these things are matter. So why can't we have an expert system based on AI for online inspection? So ultimately, all these things we can result in a good production line for this one. We can see, right, we can see that with all these things, we can make a system which can go for a production line based realization of satellite system. Next one, please. See, this one, each components in space systems are really expensive. Really expensive. The reason for this, the space environment is very harsh. Because of space environment is very harsh, it has to be of the highest quality and tolerance. Tolerance for what? One is radiation. Proton rays, electron rays, neutron rays, as well as cosmic rays, and again solar rays, so many things will be coming. So it should be resilient to all those things and all. Okay. Next thing is that one, the MOSFET what they use, we should not go for some kind of latch-up operation, and the CMOS chips what we go, should not go for single event upset and all. For this one, the components are designed, called as S level. S level means space level, highest level. So their utilization becomes most important. Certainly, we should make a good measurement before putting on the cards. So that's why passive measurement we do before testing. And when you have to make test, we have to make some intermediate point testing also on the card, which may not be possible so easily on the card because of the point of accessibility. So robotic comes of probing and testing will be there, and report generation and verification and automatically. But one of the most important thing is that space is not failure free. Space is not failure free. We see problem there also. Many conditions will not be able to simulate on ground. Okay, now. So what happens? We should try to capture the signature happening early in the design, early in the realization, so that we can capture them and video the possible problems happening in the space subsequently. That's the reason that test tools to capture early signs of degradation and performance forecasting is the most important thing where one can contribute and do this work actually. Next one, please. And of course, as I told, AI is much useful for in all these activities actually. Handling of large volumes and adaptive processing for complex data. Suppose if you say one lander has to land on a forsaken place, means unknown place, how do you do it? Correct now? You can't give that all pictures earlier and all. So you have to give signatures only you have to give. So it should process the complex data in real time. You can't say I'm going to launch after 14 days, means you would have already got the eclipse on the moon actually. Right? This is the most important. And large scale data processing, autonomy and sensor fusion. These are most autonomy and sensor fusion is the most important thing which will enable us to go for higher level of integration. Next one, please. This is one of the most important thing in the recently also we have seen ISL communication. I told earlier 2-3 occasions also how that our constellation of satellites are put in the space to give a functionality of telecommunication and other purposes. But we can see here that one, how do they communicate? For them to be effective in this one, they should communicate each other. So what happens? Inter-satellite communication links are going to become much more important. So in this one, two kind stands very promising is that one. One is one is optical, second thing is laser. Because there is no obstruction in the space, we can comfortably use them in the short distance so that we can have a good communication for a cooperative or coordinated operations. But however, to be on safer side, we go for a combination of optical plus RF so that should have uninterrupted communication happening under any conditions. Okay. You can see that one hybrid inter-satellite links are there actually. Then again, associated the technologies and challenges also we can see that how it is going to be made possible for this one and all actually. Next one, please. And IoT is a buzzword. Any conference, if you say IoT, are you working in IoT field or not? Which IoT field you know? But this one, actually, Internet of Things enable a smart in today's world. This is a collection of smart devices that help us for our domestic lives. This is for our commercial applications or our human applications. But however, next level is industrial IoT. It's interconnection of sensors, devices, machines and systems in an industrial environment for collection of analysis and exchange of data. This is also quite a good extent is also possible actually. I can have a hub in Bangalore, I can have a hub in, let's say in Delhi or the Noida NCR we can have. we can have integration. But how do you integrate these units actually? Some Pune industrial hub is there, on Noida industrial hub is there, and again we got Worli Bombay is there. How do you link them together? Correct now? There only SIoT is coming to picture. There only SIoT is going to come to picture. So what happened? Satellite Internet of Things is the one which is going to go for seamless connectivity outside the LAN and mobile networks. Okay, you can have network anywhere in the world through satellite. Okay, of course leaving some of the shadow areas. So this is the one which becomes most important, that the importance of satellite in the IoT. You can see this one actually. You have got one LAN system coming here, one IoT system coming here, one more IoT coming here. So what happens? These are going to communicate to the modem or router through Ethernet or LAN. It is going to the user terminal. It is going to be linked to satellite. It is going to, from satellite, it is going to satellite access station. It is going to the internet. Again, it is going to end users. One example for this one is, suppose if somebody is designing a ASIC chip, where are the foundries in India? No foundries, no. You can make a design, you can make simulation, you can make analysis. But how do you make the ultimate ASIC? Certainly you should have the link between the end manufacturer. You can do the work for you. This is the one place where satellite IoT or SIoT is going to come into the picture actually. Next one please. I think lunch time I'm going, no, time is done. Next is, this is the most important thing. Digital twins for satellites. Twins, you are aware, correct now? Two people looking alike, two objects having the similar features, size, feature, all those things and all. But what is a twins of a satellite? Correct now? Why do you want first of all this twins for satellite? But what is the cost of making one S1? No. Some problem has happened there, correct? You already lost one satellite because some problem has happened. One more satellite you made on the ground. That also is not useful because it's on the ground only. Correct now? But what you told only was the approach followed earlier. For the what all launch we have made earlier, we used to have one engineering model, we used to say. One engineering model. Engineering model is supposed to be on the earth. Whenever you see a problem in the satellite, in the onboard, we used to simulate those problems in the ground, get the solution and implement onboard. Or understand in case of if it is beyond our, let's say that point of any correction, we take it for next satellite like that. But as the time progressed, we also got confidence. But if you have to make all satellite one extra, how it will be costly? I told earlier itself, a large satellite costs anywhere between 300 to 400 crore rupees. Microsats may go, small satellites may go up to 100 to 150 crore rupees. Okay, microsat may go up to 40 to 50 crore rupees. How do I make a twins for each satellite? Correct now? So this becomes a question. What happens? So initially we had IRS 1E for IRS. We had inside 2E we had for this. E means that is same thing only. Engineering model. So subsequently we see that one, we should be able to replicate the functionality digitally, so that suppose you think that one, the temperature of the system has gone higher. Okay now, some configuration switch has got opened. We should be able to link such a way that one, when this configuration switch has opened or closed, it is going to impact by oning or switching on so many subsystems coming on the bus, ultimately making the temperature of the total environment to go high. So if I am able to simulate this one, I need to go for one more satellite. Correct now? I should be able to model different subsystems and interconnection of a satellite, ultimately to create the environment which is equal to the what has happened on the satellite. Okay, that's why the digital twins has taken a much important steps in particularly for making for satellite. Next one please. Now all this explained. What is next? What do you want from us now? First, we are the first to find traces of water on the moon. Correct now? Second thing is, we are first to land on the moon in the South Pole. Next, what else you want? This is, anybody can answer also this question. Correct now? There is expectation from everybody. Correct now? So what is the one you can expect? You can ask, I want a part of moon to be back to earth. Go and get a part of moon back to the earth. Okay. That is the new mission called Chandrayaan mission. This is meant for, this is also called a LSRM, Lunar Sample Return Mission. This is a very, very, very complex. What you should do, we should take the total different modules to the space. From the space, it has to go down onto the moon. We should be having a system to get the soil of moon and package in a cartridge, take it to the satellite. Okay, from satellite it has to be brought back to the earth. 5 modules are required for this total thing happening, and already the plan has been conceived and things also has been approved. You would be seeing maybe in another few years that one LSRM or Chandrayaan phone happening, and you would be able to see and touch what is the part of moon and the earth. Okay. So it requires a lunar sample collection, sample handling and sealing, and the lunar sample transfer and lunar orbit. Docking also is most important. That's why this docking only we can see that recently what our SPADEX docking has happened, undocking has happened. You should have a docking while going, undock should happen there. One should go on to the moon, again it should come back, it's called as return module, and go on dock with the orbital module, and that has to come back to the earth. The entire process are required on this one. Next one please. The same thing only water. One more thing, next thing also you can see that one after this one, why can't we go for landing on the Mars? A lander can be sent to Mars and all. So this is one more option actually what we are trying, so that we can go for Mars lander mission subsequently. This is the one actually what we are saying actually. Earlier we had MOM, you would have earlier heard that from our Prime Minister Modi ji is telling that one, the ISRO has achieved, and they have sent a mission to moon at a less than the auto price he told, auto price per kilometer. See, we can see the Mars is 55 million kilometers from us, nearest. For there, such a mission we have sent for orbiting around the Mars at such a low cost, which is less than the auto fare per kilometer. That was the achievement which has been added by our Prime Minister earlier and all. Okay, this is the one which is, next is that one Mars lander mission is going to happen subsequently. This is the one. Next one please. And why we have to leave the Venus also. So next we are planning for Venus Express, are called as Venus Orbital Mission, sending one satellite to Venus. Only thing is here, the most important thing is mission management for aero braking and payload mechanisms and spacecraft thermal management. These are the most important things is required for Venus orbital missions. So these are the things, this is only few things only I showed. The things have been lined up actually, ultimately to serve the society and for the human life improvement. All the things have been planned actually. Next one please. Certainly rapid progress, changes in technology trends, disruptive technologies taking shape across all sectors, need for strong collaboration between, this is actually I was trying to harp up on this in my supply chain management slide. Collaboration between industry, academia and R&D organization will bring in a game-changing technologies. Certainly together we can bring in constructive change in the technology sector to emerge as leaders in technology frontiers. Means to say we can be the world leader actually. See, today one point I want to make sure that one. Today software, no, you can see, you would have heard this one, so many software job cuts happening in Bengaluru, like that you would have seen. Last week some note was there actually. And if you see that article, 50,000 job cut it they have put actually. That is really disturbing only. Already would have relatives, kith and kins would have been employed so much of industries and all. So they would be, the reason is this one, no, all if you put together, in software industry, AI and ML only clocking a very good rate, about 30% growth we are seeing. In the other sector, we are seeing it is not, growth is not so impressive, only 5-6% only growth is there. Today, if you see the space sector, they are growing at the rate of around 9 to 10%. Another, if you take 8 to 10 years, the economy of space may overtake the economy of software. This is the condition is going to come actually. Certainly, this is one area should be looked in really in detail than actually what is being looked today. Next one please. Ultimately, with all these inputs, what is the technologies what we make in India should be for the make for the world actually. Okay, thank you very much. ನನಗೆ ಆ ಪೆನ್ ಡ್ರೈವ್ ಕೊಟ್ಬಿಡಿ ಅಂದೆ.
Thank you, sir. Your insightful words and address on satellite technology and its future trends are very insightful. It will surely encourage fresh perspectives and drive meaningful progress in research and academia.
I now invite Shri T.K. Nanjundappa Sir, Secretary, SSES, Dr. Shukumaraya Sir, Joint Secretary, SSES and CEO, SIT, and Dr. S.V. Dinesh Sir, Principal, SIT, to felicitate Dr. Madhusudan C.S. Sir. Thank you all.
I request the dignitaries to felicitate Sri Dayanand Vaya Sir. Thank you all. Now I request Sri T.K. Nanjundappa Sir, Secretary, SSES, to deliver the presidential address.
I submit my respectful pranams to His Holiness Sri Sri Shukumara Mahaswamiji, Founder President, Siddhganga Education Society, and Sri Siddhalingas Mahaswamiji, our revered President of the Society. Dignitaries on the dais, invitees, session chairs and co-chairs, authors, sponsors, participants from other institutions, deans, head of the departments, faculty and staff members of my dear students, good morning and hearty greetings to all of you. I am very happy to participate in this inaugural function of Third International Conference on Smart Systems for Application in Electrical Sciences and Technetium 2025, organized by the Association of Electrical Sciences. Conferences provide platforms for knowledge sharing and learning, where experts, researchers, and professionals will present new findings, innovations, and best industrial practices which will help participants to stay updated about the latest advancement in this field. This is an opportunity for all the key stakeholders meet to discuss about industry, standards, and policy matters. Any advancing society needs technological innovations for improving the quality of life. In the present context, the advances in multifunctional smart materials, disruptive technologies in communication and devices, enhanced computing capabilities are essential for smart system innovation. Smart systems are intelligent devices performing functions such as sensing, monitoring, and control. Japan and South Korea are leading in these technologies. These days, environment, agriculture, healthcare, defense, security system, aerospace, communications, etc. In spite of rapid developments, advancements, there are several challenges hindering large-scale implementation and efficiency of smart systems. Some of the challenges are power grids are IoT integrated and are vulnerable for cyber attacks. Artificial intelligence-driven automation solutions have been integrated into smart systems, and they have the risk of unexpected system failures. Shortage of professionals trained in artificial intelligence, automation, and smart systems, resulting in slowdown of smart system integration. Efficient energy storage is a major bottleneck. Upgradation of traditional power systems to accommodate smart technologies require huge investment. Lack of large-scale, fast-changing stations for electrical vehicles, battery lifespan, and recycling methods, and improvement to reduce the impact on environment. These challenges highlight the need for research and collaborative efforts between academia and industry in the area of systems. I believe that the deliberations in these 2 days conference will pave the way for discussing challenges and possible solutions. I would like to extend heartfelt thanks to all sponsors, speakers, authors of articles, advisory committee members, reviewers, program technical committee members, chairs and co-chairs of various sessions, organizing committee members, faculty, staff, and students for the wholehearted cooperation and hard work for the success of this conference. May my best wishes for the conference. I thank you all.
Thank you, sir.
On this occasion, I would like to present on memento, that is the Chandrayaan-3 memento I would like to present to the college. Basically, this should encourage the students to take up the research activities and again R&D activities. And further, whenever they see this model now, they should ignite their minds so that they should focus more on the space research also, so that they can carry out the work in this area, ultimately leading for contribution in the different sectors possible in the space area towards make in India and make for the world. This is my wish also. Thank you.
Thank you, Madhusudan sir, for your kind gesture and affection towards the institute. Now, I would like to call upon Dr. Vinayaka KU sir to propose the vote of thanks.
At the outset, I offer my humble pranamas at the lotus feet of His Holiness Dr. Sri Shivakumara Mahaswamigalu, Founder President SSES, and Sri Siddhalinga Mahaswamigalu, President SSES, and seek their divine blessing as we conclude the inaugural function of International Conference on Smart System for Application in Electrical Sciences and Technetium 2025. It is my privilege and honor to extend my heartfelt gratitude to all those who have contributed to the successful commencement of this prestigious event. First and foremost, I express my sincere gratitude to our esteemed Chief Guest, Dr. O.D. Naidu, Senior Principal Scientist, Hitachi Energy Research, Hitachi, Bangalore, for gracing the occasion and delivering an insightful inaugural address on the topic Technologies for Power System of the Future, where Sir highlighted the importance of the carbon reduction, challenges in the electrical domain towards the carbon reduction, and he also emphasized the environment, resilience, security and safety are the key aspect for this carbon reduction. Sir, your presence and word of wisdom has truly inspired us, sir. Thank you, sir. I extend my deep gratitude to our guest of honor, Dr. Madhusudan Sir, CS, Group Director, System Engineering, ISRO, Bangalore, for inaugurating the Technetium 2025 and a hobby project, and for sharing your invaluable insight with us on the satellite technology and trends. Sir has also highlighted the history and achievements of ISRO and satellites for the various applications and accomplishments of ISRO for the global space technology. Your thoughts have indeed set the tone for the meaningful discussion in the days to come, sir, and you have inspired us. Thank you, sir. My heartfelt thanks to our Honorable Secretary, Sri T.K. Nanjunappa sir, for his constant support and guidance. Your leadership continues to be the source of strength and motivation for all of us, sir. Thank you, sir. I extend my profound thanks to Dr. Shukumaraya sir, CEO, SIT and Joint Secretary, SSES, for his unwavering support and invaluable guidance in organizing this conference and technician program. Your encouragement played a pivotal role in making this event a reality. Thank you, sir. My sincere gratitude to our beloved principal, Professor S.V. Dinesh sir, for motivating and encouraging us to organize this conference and technicium. Sir, your vision and leadership have been instrumental in ensuring the success of this event. Thank you, sir. I wish to place on record my sincere thanks to Dr. Rashmi, Organizing Chair of ICSSES-2025 and President of Technicium 2025. Madam, your guidance at all the stages of this conference process has been very significant in the smooth conduction of this conference. Thank you, Madam. I wish to thank Dr. Sridhar HS, Coordinator of Technicium 2025, for your meticulous planning and execution. Your dedication and hard work have ensured the smooth conduct of this conference and technicium. Thank you, sir. I extend my sincere thanks to IEEE MCE for permitting us to organize this esteemed conference, and IEEE Bangalore section for providing the technical support for the conference by guiding us the procedural steps in the conduction of this conference. I thank IEEE Bangalore section in their absence here. A special word of thanks to Sri Dayanand sir, our esteemed alumnus and CEO of PP Pass Chip Technologies Bangalore, for his financial support. Your contribution has significantly enhanced the quality of this event, sir. Thank you, sir. I extend my sincere thanks to the member of Advisory Committee, Organizing Committee, Technical Program Committee, Session Chairs, Co-Chairs and the authors for their active participation and the contribution for this conference. Your efforts has been enriched the technical depth of this event. I extend my warm thanks to Yashas R, the Student Coordinator of Technicium 2025, for his dedicated efforts and coordinating the various aspects of this event. Thank you, Yashas. My heartfelt thanks to the Dean, Head of the Department, faculty members, staff and the students for their cooperation and support. Your involvement has been crucial to the seamless execution of this event. A special note of thanks to all the Head of the Departments, faculty and staff members of Electrical Sciences for providing the crucial inputs, extended support and coordination for the planning and execution of the conference of this technicium event. Thank you, sir. Special note of thanks to the print and electronic media for covering this event and helping us to reach the wider audience. Thank you. Finally, I thank all the participants, delegates and attendees for being the part of this ICSSES 2025 and Technicium 2025. Your enthusiasm and engagements have made this event truly meaningful. As we embark the intellectual journey, I urge all of you to actively participate in this session, engage in fruitful discussion to make the most of this opportunity to the network and collaborate. Thank you. Thank you one and all. Again, I wish you a highly productive and rewarding conference and technicium ahead. Thank you. Thank you one and all.
Thank you, sir, for thanking everyone. I thank Vinayaka, sir, for thanking everyone. And that marks the end of today's inaugural ceremony.
Hope you all enjoyed the event and good luck to all the participants. Thank you all. Kindly note, juice is arranged to the right side of the auditorium following this event. Immediately thereafter, our esteemed guest, Dr. Madhusudan CS Sir, will inaugurate the hobby project exhibition in the Department of Electronics and Communication Engineering. Have a good day.